Welcome to EDU World Space.
All right, so it's quite a lengthy problem, but let's get through it together. So we've got our mass defined like this. We have each component of the center of mass, actually it's divided by m, defined as a triple integral of x times the density function over m. It's the same for y and z, but instead of x, we're going to have y and z, obviously. All right, so the first thing that we need to do is we need to convert this to polar coordinates. And if we're just looking at the xy plane, z is 0. So then we have this guy, and this is a circle, and the radius is 1. So we can write it in polar coordinates using that there. Okay. So next thing that we do is we figure out the mass. Okay, so this mass here, what's going on? Well, there's no dependence on theta, so I integrate with theta first. There's no dependence on z either, so we just plug that upper bound right there. The lower bound is 0. And then we integrate with respect to r, and we get 3 pi over 2 as our mass. Okay. Now we need to find these triple integrals, right? Remember, x bar is the triple integral over e x density dE over m. Okay, so what I'm doing in each one of these subsequent slides is just figuring out this top portion right now. Okay, so again, pretty straightforward. We've done this in polar coordinates, so we integrate with respect to z first. We see there's no dependence on z, so we get that. However, there is a dependence on theta, so we can't do this theta integral right away. So then we integrate with respects to r. We get 12 over 15, bring that 12 over 15 out, and then integrate with respects to theta, and we get 0. Okay, so looking at y, we get basically the same thing. So I'm not going to go through this calculation, but you can see that we're going to get the same thing, except the only thing that's different is this last integral here. So let me do this in blue. So if you look at this one, and you look at this one, they're nearly the same. One is sine, one is cosine, but the integral over sine and cosine over a full period is 0. Okay, so 0. Then we come to z here. Now z is a little different. First of all, it has no dependence on theta. However, it does have a dependence on z in the integrand. So we have to integrate with respect to z, plug in our bounds, get that, do a little algebra, get this, then we integrate with respects to r, and we end up with pi over 2. Now this isn't the center of mass, or this isn't the z-coordinate of the center of mass, because we still need to, very important, divide each one of these by n. So these first two are 0, so those are fine. And now we take what we found out in this previous slide, in slide 5, which is pi over 2, and divide by our mass, which we figured out in slide 3, which is 3 pi over 2, to get 1/3. Now, summing this all together, we get these two. Right? This is x bar, y bar, z bar, and this is just m.